Hey everybody, so I'm Tyler Moody. I am a platform engineer at Sonic. Like I said, here to talk about Git strategies. Before I even move a slide, I'm opinionated, very opinionated about this. That doesn't make me right. So if you guys are in a different situation than something I'm describing in terms of these strategies, that doesn't mean anybody's doing anything wrong, because it's all about what works best for you and your team, as well as the size of the project you're working on. But anyways, so I grew up in California, just a little bit about me. Grew up in California, I went to school in Oregon, and now I'm out here getting up to no good all the time. It's great. I have a bachelor's in computer science from Lewis and Clark College, which is a tiny school out in Portland, Oregon. And yeah, platform engineer at Sonic. So I'm responsible, my team and I are responsible for anything from kind of Git strategies to project builds to actually making sure that the platform's up at Sonic. So like those 50-cent corn dog days, those are fun days. Those are great. And so we kind of touch on a lot of different processes, tech, especially surrounding how teams should kind of be running the tech side of things. So when a developer team spins up, we provide a prescriptive way of integrating with our systems, as well as integrating with some of the tooling, the default tooling they'll use, like source control. So how many people in this room use source control? I'm really hoping I see every hand go up. Git, Bitbucket, GitHub-ish, yeah, cool. All right, that's good. Always use it for everything, not just your code. It's great. Provides an audit trail, like documentation. You could technically use it as a CDN for your images if you really wanted to. I don't know how much I'd recommend that, but it's out there, right? So today we're going to step into source control, why it's important, why you should be leaning on it. We're going to kind of step into how Git works, specifically the CLI. Does anybody here use like source tree is I think one of the main, okay. Who uses command line? Any command line users here? Okay. So I'm going to say now, one of my opinions, you should only be interacting with Git through the command line. Doesn't make me right, just what I think. But anyways, we're going to go through the pieces and parts of Git, and then we're going to actually step into strategies. And so we're going to talk about how your team should interact with that tool, how your team should kind of assess that, the tool of source control, and figure out what the best way is for you guys to run your projects. Because it can vary wildly from a single open source project that you're running that's out on GitHub to a team of 12 people that's working on the same code base or the same projects. So without further ado, source control explained. There's two parts. There's Git. Git is the actual tool you are using on your laptop or on Bitbucket Online or GitHub if you're merging a pull request or something like that. And Git can be used with a series of actual source control tools. So GitHub, Bitbucket, I'm sure there's like another half dozen out there that I can't think of. But those are the two, GitHub and Bitbucket are probably the two main ones that you'll see at an actual business. And then for your open source stuff, almost everybody's on GitHub. Oh, and GitLab, which is technically separate from GitHub. I still don't understand how that all works, but it's out there, right? So the two ways you're going to interact with it are either via the command line tool, which is Git, or via source tree, which is actually performing Git commands. It's just got a really fancy UI where you can click buttons to tell it what to do as opposed to having to type some things out. And then the other thing to kind of keep in mind about source control is there's remote and local. So what that means is when you have a project in GitHub, right, that's your remote source. That's your source of truth. Whatever is in GitHub is what's really like alive. And then whatever you have on your local machine when you're working is your local. Source control allows you to have multiple people working on the same kind of remote without affecting change on each other. So you have your source of truth and you can have as many devs as you want, pull that down. They can all do their work. Once they're done on their local, they'll push it back up to the remote, and that becomes the source of truth. And this becomes a way to manage people working on different features when they're touching the same code base. So you could be in the same file making two different changes, and source control enables you to do that safely by merging those changes whenever you decide it's time to merge those changes. Also, if there are any questions, raise hand, holler. I'd much rather answer them during than after, because that's how we get the most value out of this, is everybody participates. So if you have a question, please yell. I want to hear it. Okay, so basic directory structure of a project that is leveraging Git. So there are two main things, three things you really need to look at. So the first one is that .gitignore, right? That's the green thing up top. That file is responsible for informing Git, the tool that's installed on your machine, what it's supposed to watch and what it isn't. So it tells it, hey, for these files, if a change happens, let's keep an eye on that so that we can eventually push that up to our master branch, up into GitHub, Bitbucket, whatever. Let's watch that. And it tells it what not to watch. So I change a config file that I just want to be messing with it on my local. I don't want that actually going up to the master. Well, you can tell Gitignore to ignore that. And so if you make changes, it doesn't flag that as, hey, that changed, so we need to do something about it. It just leaves it alone. A README. This is hands down the most important part of any project. Open source, on a team, your own thing, whatever. I don't care. Keep it updated. That is the integration point, the primary contract point for anybody that's going to come participate in your project. That's where you define, hey, here's how to build this thing and run this thing. Here's some of the design decisions I made up front, or the standards that I'm expecting. If you're going to submit a pull request in to add a feature to my code, this is what I need from you. These tests or documentation, whatever. So always keep that updated. And I'm horrible at it. I'll own that first thing, but it makes the biggest difference in the world, especially if you go look at an open source tool. That's one of the first decision points I make is the README solid followed by the subsequent documentation? Because if it isn't, I'm not going to use it. The last thing is this .git folder. So this is a hidden folder in the directory. This is where Git keeps track of everything, like your whole world on your local machine. So it keeps track of what's up in master, up in GitHub, and it keeps track of your local and kind of the changes between them. So whenever you go to actually make changes, commit them, and push them, this is what informs Git as to what changed and what it needs to be managing. Oh, cool, I had things on here. Important things to include in a Gitignore for what to leave out. Imported packages, local configuration files, and anything else you don't want public. So you got a sweet private key to Artifactory, or I don't know, any other tokens that you might not want shared. Make sure that those files are in the Gitignore so that they don't get pushed up. Because once that's in Git, it is almost impossible to remove. Wiping out history sucks. I don't recommend it. And I've done it by accident, and it's not fun to try to bring it back either. READMEs, like I said, testing and style standards, how to set up for your local use, and any other tips, tricks, gotchas. So this is also a place maybe to temporarily identify if there's something you're not happy with. You had to make a choice that you want to go back and revise later. And you can inform people, hey, I know this is bad, but I'm going to go fix it later, I promise, I swear. And if you want to fix it, here's where you can submit the pull request. And then within the .git folder, this is everything. This is the Git magic, right? So basically, you don't really have to mess with this thing at all, ever, normally. And I wouldn't recommend you do unless you are really comfortable with Git and know kind of what you're enacting. But everything in here is super important. So just don't wipe it out. Know kind of what's in there. Maybe get comfortable with what's in there, but don't worry about actually enacting changes on it unless you are I can't even think of what kind of a weird spot you'd be in. You'd have to have really messed up a repository somewhere to have to mess with this. So you can leave it alone. But know it's there. Know not to nuke it. Creating a project, super simple. I'm sure most of you have done this at this point, but on GitHub, you can click the Create a New Repository button when you're logged in. It's going to give you a repository name, public or private. And important things to note, there is a box that you can check that says initialize this repository with a README. This should always be checked in my mind. I think you should have to think to uncheck this, but others disagree with me, so it comes unchecked. And then you can choose to add a Gitignore. This is really valuable because you can select what language you're working in, and it will give kind of a prescriptive Gitignore as to what you don't want pushed up. So in the case of Java, it's going to ignore all jar files. So if you built your project, it's not going to flag that as a change in the project. So that doesn't find its way up into GitHub by accident. Basic Git Flow. So this is commands via command line. If you're using source tree, these actions are taken normally as well. I just didn't do source tree screenshots because I don't have it. So you make a change to a file, right? You've got this project, maybe it's Java, maybe it's Node. You change a file, and it's not ignored by your Gitignore. If you run a git status, Git is gonna go up, it's gonna hit your master branch, and it's gonna be like, hey, tell me what's going on up here. And then it's gonna compare that to your local, and it's gonna see that there are differences. So it's gonna pop up in red and say, hey, there's changes here. You need to do something about it. So what you would normally do is you would add it, informing Git, hey, I want to add these changes so that they do go up, and then commit it. So you can add a series of files and then do a commit, and a commit allows you to add on a message or like, and it gives it a hash so that you can always go back to that to see what changes you made at that point in time. So you'll commit, and that basically bundles all the changes together into one thing. And then you pull, and that makes sure that any changes that came into whatever branch you're against get pulled down and merged on your local. And Git will scream at you if you don't do this. Like if there are changes in master and you're trying to push a commit, it doesn't let you. But you'll pull, and then you'll push, and that'll actually get your changes up to your master branch where everybody else can see them. So in a team of 5, your other teammates aren't gonna see that their remote repository has changed, the master or whatever branch you're committing on has changed until you've pushed. And then they know, I gotta pull this down because now there are changes to the code base. I need to make sure that whatever I'm doing works with those. Branching strategies. All right, so there's the traditional strategy, which is actually branching. That's pretty common. In fact, it's very common. And you'll see variations on this. Some companies or open source projects will run a dev branch. So they'll have a master branch. Nobody commits on master. That's like a big no-no in that case. And they have a dev branch, and that's where you can merge changes into. And they'll have a series of feature branches. So everybody can kind of work in isolation on their feature. And when the time comes, they can merge it into dev, test against dev. If dev's happy, merge that into master, and it becomes available to everybody. The normal times for branch creation are features, bug fixes, or if you're working in an organization and they're running like a Jira board or something, basically some way to track work, you'll do it per piece of work or per card. And so typically you'll name your branch after that, and then you'll make your changes, you'll commit, and you'll open up a pull request. And a pull request basically says, hey, I want to take the branch I have and take all those changes and merge them into whatever branch you're pulling against. So in the case of the strategy I just defined where you're running a dev branch, you do a pull request into dev. And this allows for code reviews. And this is really important. This is kind of like the first piece of, you got to think about your team's processes or your open source project's processes. This is the first chance for you to review some code that someone's submitting to make sure that it is good. And by good, I mean it's got adequate test coverage, the business logic makes sense, it's commented effectively if it's complex. And so this is kind of your first place to have a team go through and assess whether or not that change is good, valid, and ready to be merged. Code reviews are done usually via pull requests on GitHub, Bitbucket, whatever. You can open up a pull request and it'll display this nice window with all the changes and you can go through and look at it. And this is where commit messages become really important too. If you have a pile of commit messages or even just one, having like a really verbose but short commit message goes a long way because it can inform people as to what exactly they're about to be looking at in your code, because code's not always easy to read. And then this is how you would create a branch. So you'll check out, you do these actions in source tree as well, but you'll check out and the -B informs Git, hey, I'm gonna make a new branch. So that branch gets instantiated on your local, and when you push, it gets instantiated on the master. So this will automatically move you onto cool branch, and then you can push, and cool branch now exists on the master, and you can continue to maintain your code across both of them. So the good, the bad, and the ugly with this. The good are feature branches and pull requests. Now, this is one of those places where my opinions diverge, but I'm trying to be, I don't know what the right word is for. I'm trying to be open-minded. How about that? So feature branches are really good when you are working in a smaller team or when you've got a lot of things flying at once. The best example I have of this is like the Sonic mobile app. When we were gearing up to release, there were a lot of small changes happening because as we steadily released the app, we were identifying things that needed to be changed, either from a like end user standpoint or from a process standpoint so that we could continue to handle increasing amounts of traffic. And so feature branches allowed us to really effectively track that. We only ever used them for like serious features, but it did happen. And then pull requests, which is what I was just talking about. And these are really, really, really valuable, especially in a team where you got like a wide range in skill. levels as well, or comfort in that language, because this is a really good opportunity for your team to come together and to review requests and to help teach and help guide people that are not necessarily as competent and inform. And it also is a good place to catch bugs before they go out. Doesn't always. Nobody's perfect. Sometimes bugs get through and that happens, but it's a good place to catch it. So the bad is merging, and the ugly is merge conflicts, and those go hand in hand. So with a branching strategy, you are always merging changes, and I mean like the actual action of a git merge, which is a little different than a rebase, which I'll get into later. Merging is okay, but merge conflicts are tough, because when a merge conflict happens, Git halts the merge, and you gotta go find whoever's changes you're conflicting with and figure out whose code needs to stay. Because Git basically writes over the files and it says, hey, I've got two sets of changes that I can't tell which one's the right one, or if it needs to be some combination of the two. So it identifies that, it informs you, and it halts everything. You gotta go find someone, you gotta figure out whose changes need to be there. And then really what you should do is you should not merge those things together in like a source branch that's used by the public. You kind of need to spawn off another branch to make sure that once you've solved the merge conflict, you've actually solved it and not introduced another bug by missing some small part of somebody's change. So from a process standpoint, it can be really painful. It can slow down your development time. It slows down your feedback cycles for sure, because fast feedback's really important for a dev team. The faster the feedback, the faster they can implement changes, the faster they can fix bugs, the faster they can introduce bugs, technically. But it allows you to push code out faster and safer to some degree. Again, merge conflicts are not the end of the world by any stretch, but they're less fun, honestly. And they're really scary if you're not as confident with Git. They could be really scary to look at because like everything panics and shuts down, and then you gotta like read through these long error messages, and it just looks sketchy. I really should have gone through these slides one more time. So pull requests, primary point of contact for your teammates. Usually when you're working in feature branches, you're working in isolation. At best, you've got a pair. So your teammates are not necessarily aware of what you're doing. They might know like, oh, that's their card name. Okay, so I know kind of what this is. But they don't really know to any strict level of detail the actual code changes you're implementing. So it can be really tough for people to get context on that, and this is a good way for that to happen. And in a team where a lot of changes are going out, or again, a team with a range of skill levels, this is a really good chance for everybody to get together, get context, teach, learn, etc. And PRs can get declined. I've been at the end of a declined PR many a time. Don't be offended, especially in an open source project. People are only doing it for the sake of their code. So just keep doing it, rinse and repeat until everybody loves you. Because at some point you'll get there. Merging branches, so we talked about this, but in a feature branch environment, like where you're doing that process, there's gonna be one branch that's like the source of truth. Typically this is master. Some organizations will spawn off a branch called like production, and they don't actually do anything with master, but they have a production branch. The biggest thing that you have to keep in mind is whatever's on that branch is the source of truth, and it must be kept safe. Because once changes are merged in, getting them removed is painful. Once again, it halts the process, it slows everything down. It's very doable, but then you've got to engage with all the engineers that had changes that you were merging, and it gets problematic. So always pull master or production or whatever into your branch before you try to push your changes from your branch into that source of truth. If there's merge conflicts, if there's any problems with it, you can identify it in that branch before it hits the source of truth. And then everybody, if it hits the source of truth and everybody's pulled, now everybody has that problem. Again, having been on the other end of this where your bug got into master and everybody's like, dude, when are you gonna fix it? It's not fun. There's some pressure there. Not much more to add to merge conflicts, quite frankly. You just gotta figure out what needs to stay and what can be removed safely. And then you can trust in Git to finish at that point. Once you've kind of identified what changes need to happen, you can continue your merge, and Git will get you there. Git can always be trusted. It will always inform you if it cannot do something or if it can. And if it says it can't, it really can't. Don't force it. It will make you very, very sad down the line at some point. Like, you might think it's okay, and then like 2 weeks down the line, it bites you, and it really sucks. So I've been describing all this stuff, but here's the actual commands for how you might use a feature branch or use a branch for your local development as opposed to against master. So assuming you are working in a project you already have, you'll check out master and you'll pull. You'll get your source of truth. Then you'll check out your branch. You'll write some code. You'll commit. And then you'll, again, go back to master, make sure that your source of truth is all up to date. Because really, you should be doing merges on your local. The only time you don't is if you're opening pull requests on Bitbucket or GitHub, which is a totally normal practice because then it's available for everybody to see and you can have people go review. But if you're doing all your merges locally, which is probably the safer way to do it, you can pull down your source of truth, go back to your branch, you'll do a git merge master. So what this says is anything that's different from master, that's new from master compared to what I have on my branch, bring it all into my branch. If there's merge conflicts or errors, your branch will be broken, but master will be safe, even on your local. Then you can check out master and merge your stuff back in, and at that point, you've already proven the merge one way, so the other way is always safe. So protecting that master branch at all costs. So strategy number 2, I love this. I think this is the right way to do things personally, but again, it varies very much on your org and on your team. It's called the commit on master strategy. So when you think about branching, trying to maintain everybody's changes across all the different branches you have open, all the work that everybody's doing is hard. A lot of devs will write scripts so that when they boot their computer up in the morning, it immediately goes out and pulls everything that all their repositories on master and on all other branches. And just to make sure that they've got the latest from whatever was done yesterday. So keeping up with that is hard. And I've had plenty of times where I've had a merge conflict because I hadn't pulled a project in like a week and I'd been working in isolation on a branch. So then I go pull master, and had I been pulling and merging frequently from master into my branch, would have been fine because they were small changes. But the huge massive changes that were coming in at that point caused problems. And it really sucks to have to back your changes out or copy paste them into a notepad or something and then pull everything and merge it and then maybe try to copy paste it back in. It's not fun. So to avoid that, commit on master was born. That and to allow for continuous delivery of code, which is the other area of my expertise. And if you're interested about that, we can talk after this. So commit on master is the new kid on the block. There are no branches. There is only master. You have to do small commits often, and you have to have a team that is tight-knit, that is comfortable with each other and trusts each other, because you're always affecting change on your source of truth. There is no safety net to some degree. So it really enforces team dynamics, and you have to have process down. You have to know that everybody's gonna stick to that process. So the good is there are technically no merges. There's always merges. These are kind of, they're a little different. So there's almost like some obfuscation in place. And if you're doing small commits, they're painless. They're very much painless. And you can be really, really fast. However, you have to have a strict commit strategy. So you have to have, hey, after a certain amount of work, you need to be committing this and pushing it. So if it's a large chunk of work, you've already got problems. It even comes down to the process of how you define your chunks of work. It needs to be broken down into really, really small pieces and then committed and pushed frequently. But it allows you to iterate really, really quick. So we can push a feature out in half a day, depending on the feature, obviously. We can push it out in half a day because we're committing on master and we're checking frequently. So we get a lot of feedback. The other good, like I was saying, stricter commit strategy, and it really enforces team dynamics, because if team dynamics aren't there, this strategy starts to fall apart and it's obvious. And so it's really easy to identify where the flaws are and like, okay, so we're not committing often enough for some things, because things start breaking. And then you see, okay, things are breaking. Well, what's going on? Well, we're not seeing as frequent of commits, or our commit messages aren't as verbose, so we don't know what people are doing. And it's really easy as a team to identify that and figure out how to fix it. The ugly is Rebase. I personally, once again, I don't think this is ugly. This is my opinion. Rebase is awesome. It is the coolest tool in the world. But it also gives you the ability to nuke the entire history out of your Git repository, which I did with one of our longest running projects at Sonic on my team like 4 months ago. And the only reason we got it back was because somebody still had the project pulled down locally with all the history. But I nuked master's history. It literally looked like there was only a single commit on there with all of our code. It was really cool. Yeah, got to own that one. That was, yeah. My nickname at Sonic is Code Diva, like that's my Slack handle, and it's because things like that happen and then we gotta fix it. I break things all the time and then have to go back and fix it. So Rebase, my favorite. Really all it does is it shifts history and it shifts, kind of can shift commits around. And you can delete things off of your remote history, which is not something you can do with a merge and a push. You can't. You can revert things, but then you actually get additional commits that you push up and it says, hey, this is a revert of this change. So it just restores it back to a previous state. Never rebase against remote master. I did not do that. I did rebase my local and then push master, but if you rebase against remote master, that's like grounds to be taken out back and told why that's not okay. There's two ways to use it. You can get rebase or you can get pull rebase. I always get pull rebase. Basically what that means is when you do a pull on a branch, it's gonna go, Git's gonna look at your local, it's gonna look at remote, it's gonna pull down remote, and then it's gonna figure out how to merge all those changes in. So if you have multiple people working on the same branch, you can even see merges within that branch and you can see their work pop up. What a rebase does is it says, okay, so let's look at your local, and if you have commits that you haven't pushed, so you have history on your local that doesn't exist on master, it basically takes those and just puts them on top of everything else that comes in. So your stuff's always the most recent, and it always does a merge, but it's kind of a merge under the hood and it's not obvious. So this can cause merge conflicts, but they're super rare. Rebase is very, very, very good at what it does. So that's pretty much the only way I do it. If you're doing a rebase, it's usually to remove commits. So if something gets committed that you don't want on your local, like for example, a config file that's got a bunch of tokens or passwords or something like that, you can rebase that off your local history without wiping all of your other changes. And that would be the first way of using it with an actual Git rebase. You'll give it a commit hash that's on your local and tell it what you want it to do with it. So team dynamics is super, super important with a commit on master and a rebase strategy, okay? Because if you're pushing huge changes at once, that could break what everybody else is doing because you're all pulling from the single source of truth. So I could be doing something, and I could have my buddy doing something, and I've worked on something for a week, and it's got thousands of lines of code, and I push that up. He pulls it down. All of his stuff's broken because it took me so long to commit, and we've now been working in isolation off the same source of truth, and it causes all kinds of problems. So you really have to sit down with your team and determine what's a valid commit size. How frequently do you need to be committing? Feature toggling, which is basically hiding your changes, if it's like a feature change, hiding your changes behind a configuration value so that if you're doing stuff, your path of code is not really available unless someone goes and flips the switch on their local. And then you also have to think about how to review code changes. And there's an implicit trust to that because there's no easy way of doing that. One way that, like the way that we do it at Sonic is, at least with my team, we have a lot of infrastructure code. We have a lot of dev tooling that the developers use. So we do our best to have environments where we can dog food our changes ourselves. But that doesn't always work either. There are some changes that you can push them and you can try to make sure that you're not affecting change on everybody, but like we have some tools that affect all code deployments at Sonic for the mobile app. And no matter how hard you try, you're not going to catch every edge case. There are times where people will come back and say, hey, you broke something. And you go, yeah, you're right, let me fix that. So we have implicit trust that we can apply changes as a team. Any one of my teammates can push a change to master, they can push it out. If it's production where it's customer facing, that's not allowed. But if it's customer facing in terms of internal users, so our developers, totally fair game. And then we go back and we review the code changes afterwards. So it gets some testing in production to some degree, so we know that those changes are gonna work. Potentially bugs are found before we even go and do our own code review, but if they aren't, then we can go through and make sure that whatever changes they made we're happy with. They're well documented, they're clear, we're happy with the way that they implemented business logic, and so we review code maybe once a week. We get everybody together and we review what everybody's worked on. And if there's stuff that isn't that we're not happy with as a team, we can bounce it back and they can redo it. They can go fix their stuff and do it again. But implicit trust. You got to know that your team is doing good work and following processes. Following processes is hard sometimes. So the usual flow for this is you'll be on master, no more branches, which is great. Significantly less commands, much easier to track what you're doing to some degree. You'll make some changes, you'll add them, you'll commit them. You better have a good commit message with master. Like, be very clear, no more than 2 sentences, I'd say, but really define what it is you're doing. Then you'll do a git pull -- rebase, and like I said, that just pulls everything down from the remote master and then takes your stuff and slams it on top. And then you can just push it up. I would recommend you run your tests between a git pull -- rebase and a git push, because like, I've seen times where we've changed tests and then my build breaks because there were tests, both people affected change on the same tests. And it doesn't mean your code's broken, it just means your tests are broken. So you gotta make sure that that's all okay. So handy tips and tricks. Some of these are really obvious. Some of them maybe not so much, but always work on your local. You can, on a lot of popular tools like GitHub and Bitbucket, actually go change files on the remote source, like on the Bitbucket UI. Don't do that. The commit messages are awful, and it's really hard to tell what all was changed. And it's also sometimes harder to tell who changed it. So there could be changes that go out that break something, and it's harder to find who did it, so that you could then find out, hey, why'd you change this, so that we don't break more things by changing it back or something like that. And then commit messages are really, really important. Git squash is another very useful tool. It allows you to bundle a bunch of commits together into like a mega commit. So if you're doing lots of changes and you're committing frequently, but you're not necessarily pushing frequently, you could be pulling to make sure more changes come in and validate that your stuff still works. Having a squash at the end can be really nice, because then you can write up a more succinct message, but it still has all of your commit history with all of your singular commits that have more details. And I would strongly recommend that you work on command line with a commit on master strategy. I have found personally that it is easier for me to like fix things that I may have screwed up when it comes to Git on the command line than it is within source tree. It's not to say that you can't in source tree. I've found that command line seems to be more flexible to some degree. But I also, again, I don't have a ton of experience with source tree, so I could be very wrong there. Oh, wow, that was everything. So yeah, basically, the long story short is, depending on your team size, depending on your project size, there are strategies out there for any team, any individual person. And you just kind of need to define what makes the most sense to you. Like a commit on master strategy for a single person working on a single project, yeah, that's fine, because source control is still doing what you want it to. It's making sure that you never lose track of your code, and it's making it easy to identify when changes have come in. But you got like 20, 30, 50 people working on an open source project out on GitHub. You better have a branching strategy, because otherwise it's going to be impossible to tell who did what and when something broke. And trolling through Git history is not very fun. So, yeah, any questions? All right. I'll hang out until the end of time. Sure.
So earlier, you kind of reviewed like code reviews. Are there any basics that you look for that kind of makes a good code review? Are there any So earlier you had mentioned code reviews, and I was curious if there's any sort of basics to look out for when reviewing code that makes a code kind of better than like the next code or block, or what? I guess, are there certain things that you kind of like look for, like a criteria, so to speak?
Yeah, so if we have to do a feature branch, which happens occasionally, and we do a pull review because it's something massive, typically we try to get a number of stakeholders on that code available. So people that are experienced with that code base, people that have an understanding of everything that it's doing and kind of like where the bodies are buried, so to speak. And we basically try to make sure that whatever change is being affected is not affecting what already exists unless it absolutely has to. Smallest possible change for biggest possible impact, while still keeping the code very readable and verbose. I personally I don't mind putting comments in my own code, but if somebody is trying to merge in code that has comments, that's a little bit of a smell to me. Basically, that says to me that something is going on that's not obvious. And chances are there's a way that we can refactor that to make it more obvious, where if you read through the code, it might take you a couple minutes, but you can definitely piece together everything that's going on. So you don't have to pull up the commit history, find out who did the changes last, go find them and be like, dude, what were you doing here? Because I have no idea. Even with your commit or your comment, it's not very obvious. And then the other things to look for, it varies from language to language. JavaScript is one where, like, if I see global vars, that's an automatic decline. That is like a huge red flag of this needs to be refactored in a smarter, more modular way so that you can't accidentally affect state changes across the whole application. And like for a lot of the tooling that we do too, we're writing a lot of integrations is really what it is. So like the biggest tool that we have that we work on is a CLI tool that we use to do, I mean, a pile of things, but one thing is like publishing artifacts to various sources. And so if we were going to make a huge change and there was going to be a pull request going in and it was changes to how that integrates with whatever like source we're using. So that could be Artifactory, that could be, I think GitLab does artifacts. I mean, there's a number of them, right? I would go look at API docs and make sure that whatever we're doing for our change makes sense in terms of the API. You know, we're not going to lean on things that are deprecated. We're planning for whatever the future state is that's coming out, making sure that we can extend whatever changes have been made in the future if we need to. Like extensibility and modularity are really important. Any other questions? All right, well, I'll hang out until end of time. If you guys have any other questions, feel free to ask or just come chat. Thanks, everyone.